This is a walnut. This is an HTTP server. Just kidding, it's the other way around. To be more precise, it's the smallest HTTP server in the world, and I mean it. No one publicly hosted standalone interactive website inside a nutshell before. Quick explanation for non-tech people, my nuts are literally hosting websites. HTTP is the most popular protocol on the internet. It serves every website, YouTube, Instagram, Wikipedia, you name it. Let me open browser on my desktop, and this website runs 100% on this nut. There is no hidden parts or tricks. It's HTML, CSS and even JavaScript. As you can see, I can even send my walnut to space with this cool JavaScript animation. How I managed to fit interactive website in such a small space, how it works, how it's powered. I promise in this video you will learn a lot of cool stuff. Let's go! Okay, the goal is simple. I want to fit whole server inside a nut. No cables, no proxies, desired budget, let's say $15. I have basic electronic knowledge, but I know nothing about walnuts. Before I buy any electronic components, I need to pick up a few nuts and take some measurements. I did some research and found a few fun facts. For instance, China and the US are the biggest exporters, though that's not relevant here. What is important is that English walnuts, Junglands, Regia species are typically the largest, measuring 30-40 millimeters in diameter. I'm not sure about the hardware yet, but I believe I can keep the design under 30 millimeters, so an average English walnut should be more than enough space. Mission 1: visit my local market to buy some nuts. I paid $3, but I have literally 20 of them. One costs just a couple of cents. Recently I did a video comparing all ESP32 boards, so I know the new ESP C6 chip can easily handle lightweight HTTP server. I did some research and found XIAO C6 is as small as 21 x 70.5 mm, which is over 27 mm in diameter. Moreover, it has pads for a single LiPo battery with built-in overcharge protection. Sadly, no over discharge protection, but screw that. Besides, I need some switches, so let's order those parts. In the meantime, I start preparing the nutshells. The work wood is fun part for me. I am using two multi-tools, one bigger for cutting and one smaller for sanding. The hardness of the shell surprised me. It's no wonder a nutcracker is used for eating nuts, since it's much easier to crack them than to cut them. Finally, my grinder won the war, so next I can dig out the center of the nut with a screwdriver. Every square millimeter counts, so I will sand it down to make more space. To keep the halves together, I came up with neodymium magnets idea, but I don't have any small magnets, so let's order some and wait. The next day they arrived. Shot out to Polish paczkomaty. I suck at geometry, so I actually ordered magnets that are smaller than I need, but let's do some precise drilling and try to glue them in place. You are lucky I didn't become a surgeon. Of course, I mixed up the magnet poles and had to glue them twice. Cool, I really like that clicking sound. Now it's time for the circuit. For the power source, I am reusing a battery from an old vape. These are fitting perfectly, are free and ecological. XIAO board for the brain and a tiny power switch. This board handles the power management itself. We can charge the battery with USB-C, which is a super cool feature of this board. It also has Power MUX feature, which automatically switches between USB and battery with zero downtime. Let's put it all inside and solder it up. Final checks to make sure that the cell operates in expected range. I'm gonna use double-sided tape to keep it in place. It fits in one half. I can easily place a second battery in the upper part, but these batteries are quite dense, so a single 400 milliamp hours with proper optimization, should last more than a day without charging. Cool, now it's code time. It has almost 300 lines of code, but don't worry, about 90% of this is just HTML boilerplate. The full code is available on my GitHub. This is just a quick overview. I stored the website in the chip's memory and I am serving it directly to the client. The ESP can't natively run JavaScript, but that's not a problem because I embedded the styles and scripts directly inside the raw HTML. It's executed on client side. If you look closely, you might notice there is a walnut image on the side. I can't include messages as separate assets because microcontrollers don't have a traditional file system. Instead, I used a trick. I converted the image to base64 format, which is a convenient way to embed images in textual form. With the default setup, the battery drained after around 8 hours. However, I implemented 3 optimizations that extended the battery life to over 24 hours. First, I reduced the CPU frequency. Second, I put the RF transceiver to sleep between router beacons. Finally, I lowered the Wi-Fi transmission power. This reduces the Wi-Fi range, but since my router is in the same room, it didn't degrade performance. Future optimizations. It fits, it's small, but can we do better? Let's take a deeper look at the C6 board. It's super small and tightly packed, but we can make it even smaller. Typically, you program these microcontrollers using Arduino IDE via USB cable, as I did, but actually you don't need USB at all. There is a trick. I can program these boards by connecting to the raw TX-RX pins and use external UART USB converter. Uncomfortable but doable. Next in line for trash are all GPIO pins. Typically they are used to connect external sensors or motors. We don't need them at all. Besides that, ESP offers 3 types of products. Dev boards like XIAO, ESP modules and SoC system on chip. It's bare silicon. The last one is a couple of times smaller than the module. Very tempting, but it's not worth the hassle. The chip still needs a bunch of things around to work properly. For example, Wi-Fi antenna routing requires precise impedance matching and very strict PCB layout. Very easy to screw up the Wi-Fi range. I'm just too dumb to design it properly, so let's proceed with the middle option. Module. Module to work properly also need external components like bunch of resistors or capacitors. These parts are so small. Take a look at this resistor. It's like a grain of sand. Soldering them by hand would be a very hard task. I prepared a project, squeezed it to roughly 50% of the shell size, but PCB assembly price with multi-layer PCB is much bigger than I expected, significantly exceeding the assumed budget, so finally I didn't print it, but I'll attach Gerber file in the repo of this project if someone wanna try. Disclaimer, I'm amateur board designer, so layout is pretty ugly and there may be some logical errors, so please verify it before spending 150 bucks on that. That's it for today. Thanks for watching. Subscribe for more and hopefully see you soon.